Right, I think we're recording. Okay. Just get the slides up. All right, everyone. Yeah, welcome to session 2 of Intro to Blockchain Analytics. Yeah, this isn't actually the live session that we did with our guest speaker. It's the re-recording. And I'm re-recording this partly because it turned into sort of a live debugging session, and so a lot of people gave feedback and said it was a bit confusing. And so I thought I'd just re-record me presenting the slides I made, and hopefully that makes things more clear. So yeah, let's just get into it. Yeah, actually, before we start, the slides will be in our Discord, so if you scan that, you should find the slides there. And yeah, so today we'll cover the Ethereum virtual machine. And for those who don't know what that is, we'll get into it, but I also suggest that you watch our Blockchain 101 series session 2, where we cover Ethereum. And we'll also be talking about the concept of transactions, traces, and logs in the Ethereum blockchain. And then I'll also cover June raw tables. And so the raw tables are just tables that store Ethereum raw data. And we mentioned last session how this whole like data infrastructure in crypto works, or generally works. And you have a blockchain, and we covered what a blockchain is before. And in each block, you have a data. You have a bunch of data. So essentially, a blockchain is a type of database, and it's unique. Or one of the ways it's unique is it has it's decentralized, so it has a lot of different entities storing the same content of the database. They all store the same database, and every entity that stores the database verifies new information that comes into the database. And you usually call these entities nodes. And so what you have is a distributed network of nodes that communicate with each other. And you have companies like Infura and Alchemy, which are like the two logos I put, the orange and the blue one, in the circle. So that provides services like what you call nodes as a service. And so they'll run nodes on the Ethereum blockchain and allow people to request data from those nodes, so that we or like anyone don't have to go, they do not have to go through the trouble of setting up a node, because that takes up a lot of computational effort, as opposed to just requesting information from someone who does. And so companies like June Analytics, who are sponsoring this series and the platform that we use as part of this series, and other companies like Flipside, which is the black logo I put underneath June Analytics, they send requests to these nodes as service companies, and in return they get the data they need. And this data is what we call the raw data of Ethereum. And then Jude and Flipside go through the hard work of aggregating that data, cleaning that data, filtering that data into other data sets that people can potentially use. And I'll also go into that in a few more slides. And yes, like so far in this series, we've only mentioned that in a block there's a bunch of data. And so going a bit deeper into that, like as in what the bunch of data is, in each block you normally have a block header, which is just the it's just the identifier for the block. And then you have like a parent hash, state root, receipts roots, transactions roots, difficulty, gas use, and nonce. And then in the body of the block you have a list of transactions. I'm not going to go too deep into like each particular one, because we go into detail in all of these in our blockchain 101 session 2. But another good article to read to understand, it's a bit outdated, but it will give you the general gist of how Ethereum works, is there's an article called How Ethereum Works Anyways. Can't remember who it's by, but if you just search it up on Google, it'll be like the first link. But a caveat is that article was made when Ethereum was under proof of work, and now it's under proof of stake. So like the mechanisms are a bit different. Yeah, so I think I'll just touch on roots. And so for those who don't know, that the Ethereum blockchain, because it has so many people storing the same amount of data, you need to create an efficient way of storing that data. And so you have data structures called Merkle trees, and you can compress a bunch of data down to a single root. And yeah, just thought it'd be interesting to know that. Read up more on it if you want. And each transaction has its own set of data inside it. And so, yeah, you'll have like the value data, the gas price, the gas limit. And again, we go into this in our blockchain 101 session. Yeah. And yeah, like I mentioned before, because because there are so many participants in the network that store like all the database, that store the whole database in Ethereum blockchain, you have to come up with an efficient way of storing data, and storing array strings and integers take up a lot of data. And so generally, blockchains solve this problem by compressing things into bytecode. But you can't just compress things into bytecode and then it's just expect people to be okay with that. You need to have like a sort of standard for compressing bytecode. And so the Ethereum blockchain uses what you call an application binary interface. And so developers and coders will code smart contracts in Solidity. And for those who don't know what smart contracts is, watch the 101 session or Google that. Yeah, so they'll code in Solidity, and Solidity is a very high level language. And like, yeah, if you read the code, you could sort of get the gist of what's happening, especially if you're a coder and you know JavaScript. But again, like I said, it's very inefficient to store like data and interpret data through. I mean, computers generally don't understand strings and integers anyway. They can only speak in zeros and ones. So that code has to be compiled. That slide is wrong. It says code is compiled in an Ethereum virtual machine. It's not compiled in an Ethereum virtual machine. It's compiled in a compiler, which is sent to the Ethereum virtual machine. And then it's deployed on the blockchain. And so an application binary interface basically allows people to read and write from the blockchain in a way that you understand the data, because you can't understand zeros and ones. And so yeah, ABIs convert high level code to bytecode that the EVM understands, and it also allows you to read back the bytecode stored on the blockchain. And so yeah, I think I'll go into transactions now. So we covered this before, but I just want to reiterate that the Bitcoin uses a UTXO model, which is basically sort of like you start off with a blob and it gets split into different blobs, and at the end of that whole chain of blob splitting, you'll normally have like some balance or unspent tokens, and that's your balance. Whereas Ethereum uses an accounts model. And so yeah, so there are different types of accounts in Ethereum. So you have externally owned accounts and contract accounts. So externally owned accounts are basically just like what it's set up by me and you, and contract accounts are just accounts where code sits. Okay. And it's a very important distinction to be made in Ethereum between those two, because only externally owned accounts can initiate a transaction. Contract accounts just have code sitting in them. They can't initiate something. They can be called and then call another contract as like a chain of events, but they can't be the ones at a contract can't be in the beginning of a chain of transactions. So yeah, what else is there to say? So yeah, transactions are just cryptographically signed messages. They can be money, they can be information, and it's always again has to be generated by an externally owned account. And then, like I mentioned before, that contract account can call another contract account as part of a chain of events, and usually that would cause an internal transaction to happen. And we normally call these traces or function calls. And these are like the most atomic transactions happening on the EVM. They don't modify the state of the EVM, and they're not sorry, they do modify the state of the EVM, but they're not stored on the blockchain because it's part of like an internal change in state. And so anything that's stored on the blockchain is usually like what happens right at the end of the chain, so the output of the transaction. And then you also have the concept of logs, which are just events that are emitted at the end of a function call. And again, these logs are usually up to the discretion of the developer who's coding the smart contract, because they can choose to emit an event at the end of a function call or not. But usually they will, because it just makes people's lives easier in terms of decoding stuff. And we will go into that in detail in a few slides. And I think this diagram just, I guess, brings it home a bit more. So like if someone was to call the transfer function of an ERC20 token, and an ERC20 token is just the standardized format of a fungible token on Ethereum. So a token that you can exchange and has like to like value. And so when you invoke the transfer function, you're basically saying, I want to transfer this token from this address to this address. And so externally owned account, we'll start with the externally owned account, we'll call the transfer function and sign it. And we go through the concept of signing in session 1 of blockchain, intro to blockchain series, or blockchain 101 series. So yeah, an externally owned account, a wallet, me and you will call the transfer function and sign it. This will invoke the transfer function in the ERC20 token smart contract. And normally the function will look like transfer, and then you have the parameters inside, address to, and then the value. And when that function, when the externally owned account calls that function, you'll have a transaction start, and then you also have a function call, so a trace, because you've called the transfer function. And at the end of the, well, I'll bring it up in a second. At the end of the, wait, let me just get this up. USDC. Let's go for those who don't know, USDC is just a stable coin. So it tries to peg to the dollar. So if you go into, I'll go into this a bit more later, but I've just searched up USDC on Etherscan, which is a block explorer. Don't worry if you don't know what that is, but I just want to show you for the purpose of demonstration. If I go into contract, readers proxy, again, don't worry about anything I'm doing right now. I just want to show you something. And then I just search for the transfer function. Yes, function transfer. Yeah, where did you go? Yeah. So there's a function in the USDC contract called transfer from, and then you have a sender, you have a recipient, and then you have an amount. Kind of simple, right? And then right at the end of the function, an event is emitted. So yeah, actually this slide might be wrong in terms of, I've said transfer is the name of the function, where it's transfer from, as you can see clearly here. Oh, how do I get this Explorer back? Sorry about this. All right, give me a sec. Where it's gone? It's disappeared. Okay, anyways, you can go back and rewind. Yeah, so you just saw in the code that there's like at the end of the function, there's like an emit sign. So it's emitting an event. And again, that's up to the coder's discretion if they want to include an event in their code or not. But it just makes life easier. But it does cost gas, which is something to consider when coding something like this. And so going back to June Analytics, they have raw data sets available, which you can find here. So yeah, we've gone through this last session, but if you go to June Engine V2, then you have like raw blockchain data, and then like you have blockchain data for like a bunch of EVM compatible chains, and Solana as well. And if you don't know what EVM compatible means, don't worry. It just means that well, I think we went through this last session, but it's just basically blockchains that sort of understand each other and speak the sort of the same language. They're like Spanish or Portuguese. But yeah, let's search up Ethereum. And so yeah, you'll have block data, logs, traces, and transactions. Don't worry about this one. This is just information about each block that gets produced on the blockchain, and you can like see all the different fields that these tables have. But yeah, we will get into each of these three tables at the bottom in this session. But yeah, this table on the right basically shows what you could find in a transactions table. And so you have the data of, you have block information of the transaction that the block was in. And then you have data. So this is normally the input data, which causes the transaction. And again, I'll show you this in the next slide. From to simple, like who is signing the transaction and who is at the receiving end of the transaction. And then you have gas related fields. Gas is just like transaction fees. Success. So you also have stored transactions that necessarily did not get executed, so they got reverted. And we go through this in blockchain 101 session 2. And then the value, self-explanatory, and then the hash, which is just the hash of the contents of the transaction. And again, we go through hash functions in both session 1 and session 2, I believe. And so yeah. So yeah, let's have a look at June's Ethereum transactions table in more detail. Where is it gone? Sorry, just give me a second. Yeah, I just got a new laptop and I'm just trying to figure out how it works. It's so annoying. Okay, you know what? I'll just search it here. Yeah. 10 seconds should work. Okay. Okay, sorry about that. Let me just slide this over here. Yeah, so let's just have a look at Ethereum transactions table on Etherscan. So kind of simple. Select all the columns from this table where the data is not 0x. Don't worry about what 0x is for the next 30 seconds, because I will explain it. And so yeah, you get 10 rows, and then this sort of data you have again block, gas info, the value, nonce index. Kind of unfortunate that Ethereum devs, Vitalik and Gavin and Charles, were not from the UK, because I think they would have come up with a better name than nonce. But yeah. Okay, yeah, I'll get into this. But just as an exercise, let's have a look. Where's the transaction hash field? I say, okay. Yeah, let's just have a look at this transaction hash in Etherscan. It's a bit embarrassing. You can see all my tabs. Etherscan. So in this transaction, it seems, yeah, someone transferred DAI, which is another algorithmic stablecoin, from this address to that address, and they interacted with this smart contract. So again, if you go back a few slides where I showed that graphic of EOA, an externally owned account calling a smart contract function, so like the transfer function, and then invoking a transaction and also invoking a trace, and then at the end emitting a log, which you can find here. So it's emitted a log, and you can also even view the source of the code. So yeah, it takes you to the event code. And I just did a bunch of stuff. Don't worry, I'll again reiterate this as I go through more examples in this presentation. But generally, Etherscan is just a place where you can find like all data Ethereum, like all raw data, all transactions, traces, blocks, anything. And it's put out in a really nice format. And so yeah, you can see the input data was the function, was calling the function. Yeah. And you can also decode the input data here, and it does it for you here. So it's like this is the address and this is the amount. Yeah, gas information. Then you can see the logs, and then yeah, this particular transaction doesn't seem to have any traces because normally you have an internal transactions tab here, but I will go through an example in the next slide probably where I do have a look at that. But yeah, just as an exercise, I'm not going to do it here because I don't want to go over time. Change this to equal 0x and then try and deduce what sort of transactions those are compared to the ones in this table. And hopefully that should give you an understanding of what an empty input data, because a 0x is empty input, an empty input data field transaction looks like. But yeah, let me just, yeah, let's go to traces now. Yeah, okay. So yeah, like I mentioned, traces are like internal atomic transactions that change the state of the EVM, but are not stored on the blockchain. So they're like normally within the chain of events. They're not like in the beginning or the end. And so yeah, let's just quickly get into it. Yeah, I've just prepared these queries from before just to make things run faster. So yeah, let's just have a look at. So you can see it stores the hash of the transaction that the trace is part of. And so if you go back to Etherscan and search, just copy and paste this transaction hash. And I'll show you a bunch of things that just happened. And for those who are just like completely confused after seeing this, what's basically happened is someone has swapped on a decentralized exchange called Uniswap, and it's interacted with the router contract. And I'm guessing what's happened is that the routers just routed transactions through different. Actually, what is happening here? Yeah. So yeah. Okay. Yeah. So you have someone wants to swap from USDC to a coin called Sani. I guess it's a meme coin or something. And so what Uniswap has done is it's calculated the most efficient way to do that. And I'm guessing there isn't a direct USDC and Sunny pool. And so what it's done is it's swapped USDC to wrapped ETH, which is just Ethereum, but in the form of an ERC20 token instead of a native Ethereum. And then it swapped that wrapped ETH to Sunny, because I'm assuming there is a pool for Sunny paired with WETH. So that's basically what's just happened. And then you can see here there's an internal transactions tab here. And so there's been a call. But normally you should toggle this to show all the internal calls. And you can see there's been a bunch of calls. So there's been 29 internal transactions. And so yeah, so you can see here there's 30 rows. And this is because you have 29 internal transactions, and then in traces, what's nice is you also store the transaction. So yeah, and again, this is a different example in the slides for a different transaction, but again, same concept. You have 13 rows, and then you go to Etherscan, search the transaction hash, click the internal transactions tab, and then toggle for advanced view to see all the calls that have happened. And then you'll see there's 12 traces, or for that particular transaction hash that I put in the slides. But 13 rows from Juno returned, and that's because the initial transaction has an empty trace field. And so you have the 12 traces and then an empty trace for the transaction, for the initiation of the transaction. And you also notice that in Etherscan, you have like call _0, call _0 _0, and then you have static call _1. Don't worry about the distinction between call and static call. You can read that up. I'm not going to go into it in this session. But you would also notice that like you have call _3, call _3 _0, static call _3 _1. And what's happening here is calls are calling other calls are initiating other calls. So traces are initiating other traces. And so you have like you can store the chain of like how many a certain call will initiate more of, if that makes sense. And then there's actually a field in June, I believe, that shows this. Yeah, so like the trace address. So like this is the empty one. So this is like the initial transaction. And then this is the first call. And then under the first call was this call, and then you have more calls initiated from this. And so yeah, you can keep a track of like the chain of traces. And then yeah, so like you have logs as well. And again, I already mentioned that they're just events stored, they're emitted by certain parts of the smart contract code, and they're usually at the end of a function call to indicate that something has happened, something has been executed. And events are completely like arbitrary. Like the coder can put in an event and it could be anything. Most of the time, or hopefully almost all the time, it will give you some useful information about what's happened. And yeah, logs have on the Ethereum blockchain have up to 4 topics. So you have topic 0, 1, 2, and 3. And that's just purely because of how the EVM has been designed. You can search up why it's only had 4 topics. Yeah, so and topics are basically index keys of the event. So a developer who's coding their smart contract can choose to have up to 4 topics. Well, technically 3, because the first topic is actually the hash of the function with only the data types of the parameters passed. So you have the transfer function, and normally you have transfer to, from, value, right? But to and from are of the address type, and value is of a uint256 type. And so hash that exact thing in the blue box is hashed, and it produces what's in the yellow box, and that'll normally be your topic 0. So going back to this, you have a coder has the option to index 3 topics, which basically means you can, how do I explain this? You can basically separate out 3 different things apart from the function signature, so the hash of the function, which makes it easier to decode, I guess, but it also costs gas. And then everything else that's not indexed, all the other parameters of a function that are passed in that are not indexed, they're in the data field. And usually I can show you a demonstration of this. So like, yeah, let's have a look at this one. So this is how it's stored on the blockchain, right? So you have the transfer function, an address, a destination. So this is short for source, destination. I don't know what this means, but it's the value that's being transferred basically. And so you can see index topic _1, the address. So it's been indexed as its own separate topic field. And then you have the destination address, which has also been indexed as its own separate field. But then the value that's been transferred, WAD, whatever that stands for, hasn't been indexed, and so it will be dumped into the data field, and this is how it's stored on the EVM, and so you'd have to decode it to get it back to this data type. And so this is the raw amount. I'm not going to go into what that means because then I'm just going to digress too much. Yeah, so like I mentioned, you can change the drop down option to hex to see how it's stored. And you will also see more leading zeros, and this is because the EVM stores all parameters that are passed in as 32 bytes, even though addresses on the Ethereum blockchain are 20 bytes. So to pad it to 32, they just add 12 extra zeros at the end. And I think I go into this. Yeah, I do go into this. Okay. Yeah, I already explained this. Feel free to have a look at the slides to remind yourself. Uh, oh yeah, I should also mention that on June, topic 0 is actually topic 1. Topic 1 is actually topic 2. Topic 3 is confusing. Just everything is shifted to the right by one index. So instead of topic 0, you have topic 1, 2, 3, 4. But yeah, hopefully that isn't too confusing. Yeah, I mentioned this before. 12 leading zeros. You have the 0x, 12 leading zeros, and then the actual address. And it's because the EVM stores everything in 32 bytes, even though addresses on the Ethereum virtual machine are 20 bytes. And that was declared by Gavin Wood, who created the Ethereum virtual machine. So if you want to learn more about data types and how much memory they store, then I highly suggest looking at the official Ethereum virtual machine docs, which are quite useful. But yeah, like if you have raw data and you have instances like this where you have 0x12 leading zeros and then the actual address, you'd want to clean that up so that it actually shows the address properly. And so you can do so using this query that I've written here. So this is the USDC contract, I believe. And this is the function. This is what you get when you hash the transfer function in that smart contract. And I got this just from going on Etherscan and searching for it, but there are other ways you could do it. Yeah, so take the transaction hash, take the topic 1, which again will just be this, because I filtered for it. And then I've used the concat function, which basically concatenates strings together, and I've passed in two arguments, so 0x, and then I've taken the 40 string characters from the right, and that's because each byte is 2 characters, and so because an address is 20 bytes in its string format, it's 40 string characters. And so hopefully that made sense. And so yeah, if I run that, it wouldn't take too long. Why is it taking so long? Oh yeah, cool. Right, what do we do? I guess I've just shown you how to decode stuff. Like you have the transaction hash, you have the topic, which is transferring, then you have the from and to address, and then you have data field, which hasn't been decoded. So June very kindly have made this function byte to numeric underscores v2, which basically takes the bytecode stored in the data field. And we're lucky here because the data field only has one piece of information, which is the value. But if you have multiple, then you need to account for that when you're taking the substring. But not going to go into that. I'll let you sort of play around and figure that out if you want to. Yeah. So I take the substring of from 3 because we don't want the 0x here. And then the next 32 string characters. Sorry, the next 32 bytes, which is the next 64 string characters. And that just basically converts the string hexadecimal, which is a string version of a number with base 16 to a number with base 10, which is what normal people deal with basically. So yeah, let's just run this. So that we're basically decoding the data field as well. So far, I've just basically introduced you to the concept of transactions, traces, and logs. And like, if you understand these, and if you learn how to decode different transactions, traces, and logs, then you're basically like 90% of the way there in being like up to industry level in terms of understanding blockchain data as an analyst. And so if you understand this and you get like comfortable with dealing with raw data, then I'd say you've come a long way. And so like the next few sessions will probably be less, I don't know, intense is probably the wrong word, but like less cumbersome. Yeah, because we'll be dealing with like clean data that has been in which the raw data has already been used to create that clean data set. And so you're not going through like the hard trouble of figuring out, oh, what does this bytecode mean? I will also touch on a few examples of decoding stuff with raw data, but it won't be the focus of the sessions. And so I'd say this is probably the hardest session this term. It's probably another session, probably the last session next term, which is slightly harder than this. But apart from that, every other session is probably more teaching you about blockchain concepts plus just teaching you more SQL, I guess. So yeah, if you understand this session, then you're good. Yeah, I don't know why this is taking so long. I think it might be good to do with like this function, but I'll wait for that in the background. Yeah, I've already explained this. Yeah, so I don't know if you remember, but like I guess 5 or 10 minutes ago, lost track of time, but you would have seen a raw amount. Actually, I think I still have it here. Yeah, you would have seen a raw amount. This so like this event that's being emitted has said from this address to this address, this amount of DAI, which is DAI stablecoin, has been sent. Well, you're probably thinking, okay, that's a massive number. So what's and you can see here it's actually $485 that's been sent. Where here's it's saying 485 and all of these zeros. And the reason is because every ERC20 token has a decimal field. So if I click on DAI stablecoin here, you can see it has 18 decimals. And so what basically happens is when numbers are stored on the Ethereum blockchain, they're not stored in floats, they're stored in like absolute numbers. And so to store a float, what happens is it's multiplied by a certain number. And so this is that number, 18. And so to get the actual number that's being sent, what you have to do is divide this number by 10 to the power of 18. I don't know why they do that. My like initial guess is that floats are more data intensive to store, and so they opt for storing just a larger number with the decimal shifted. But I actually don't know. Yeah, okay, I don't know why this is still running, but you can run that in your own time, and you should see that you'll get values instead of bytecode for the data field. And then you can verify if your results seem correct by copy and pasting the transaction hash into Etherscan. And I highly encourage you to like play around with Etherscan just to get a feel for it. But yeah, I think we're good now. I think that's it. And yeah, so like I just mentioned before, like how you have raw data and it's clean and filtered to decode it. Well, it's used to decode events and calls, which allow you to make sense of things that have happened in different decentralized protocols like OpenSea, LuxRare, SudoSwap, which are all NFT marketplaces. And then you can aggregate everything in the orange rectangle to create what we call spells, which are basically clean, filtered, aggregated data. And we went through this in session 1 where I showed you a few examples of what that table looks like, but it's much more human readable, much more intuitive to use. And for the rest of the 2 sessions this term, we'll be using spells, I think. Yeah, we are. Cool. And as an extension, I'd say read up on more string manipulation functions. So we looked at write and concat this session. There are so many more, and if you master them, then yeah, that'd be really good. Play around with June, try decoding a log event yourself, so play around with Etherscan as well. And next session, we're going to be talking about decentralized exchange data. And I will also introduce a few new SQL concepts, so like window functions. So you have the rank, dense, rank, row number, lead, lag. These are quite useful, especially with like moving averages and stuff like that. But we'll also explain the concept of decentralized exchanges, so what automated market makers are and what aggregators are. And again, like I mentioned, we'll be going through the spell that is dex.trades. And we have a guest speaker coming in, and when I tell you he's amazing, he is amazing. His name's Kofi. I met him in Berlin for the first time like 2 months ago, and he's an amazing presenter as well. So I can guarantee you that the content that's being delivered is good. And there'll be pizza, potentially donuts. We'll see. And yeah, hopefully I see you there. Huxley 213 Claw 615. And again, I will put a form in the Discord for to track attendance for people to collect like merch and badges. But yeah, thank you. Right, let's stop the recording. How do I do this? Stop sharing. Oh, stop recording.